and welcome to today's webinar on using the What Works Clearinghouse, or WWC, studies database to support data collection for meta-analyses. I'm Chris Weiss. I'm a senior education research scientist at the Institute for Education Sciences. I'm here along with Lauren Schur, partner and principal researcher at Concentric Research and Evaluation, Josh Polanin, senior research scientist at Development Services Group, and Ron McCowan, a senior researcher for Decision Information Resources Incorporated. Today, we will be discussing how researchers can take advantage of the information accumulated through the WWC in pulling data together to support other systematic reviews, such as meta-analyses. The What Works Clearinghouse reviews existing research on education programs, practices, products, and policies to provide educators with the information they need to make evidence-based decisions. We have examined over 10,000 studies and make the data from these reviews available to not only education decision makers, but also to researchers interested in meta-analysis of our data. We're excited to have the opportunity to tell you a bit more about it. But before we begin, let me turn it over to Lauren Schur to discuss some general housekeeping issues.
Thanks, Chris. Good afternoon. So before we begin, just a little bit of housekeeping. If you have a technical issue, you can send a chat text to the organizers, and they'll respond and try to fix it for you. This presentation is being recorded. We're going to make it available on the IES website. Information on how to access the recording will be sent out to everyone who registered. If you can hear me, then you've already joined the audio. You can either have dialed in by telephone or use the voice over IP. We're muting everyone today so we don't hear your background noise, and we're going to address questions at the end of the presentation, but we encourage you to submit questions via the question panel on your screen as you have questions. So I'd like to start with a brief overview of today's presentation. We will focus our discussion today on answering the following question. How can researchers use information from the WWC website to obtain study-specific information that can be incorporated into a meta-analysis? This presentation assumes a basic understanding of meta-analysis and familiarity with the WWC website. For more information about the WWC, please consider reviewing resources provided directly on the WWC website, including an introductory webinars. For more background information related to meta-analysis, we can provide some useful links with the archived recording of this presentation. Josh will begin our discussion today with a brief overview of meta-analysis and systematic reviews, differentiating them from what is traditionally called primary research or original research studies, as well as narrative reviews. Josh and I will then discuss the key steps in conducting meta-analyses. Specifically, we'll talk about formulating a research question, developing a protocol, searching the literature, gathering study-specific information, and preparing a meta-analytic data set and analyzing and reporting results. Throughout the discussion, we will show how researchers can use WWC resources to support their meta-analytic review efforts. I'll now turn the webinar over to Josh, who will provide a general overview of meta-analysis.
Thanks, Lauren, and thank you all for attending. My name is Josh Polanin, and I'm excited to be here talking about what the WWC has to offer to those of you who want to conduct an original systematic review and meta-analysis. To start my presentation, I'd like to begin by laying out some terminology. As you all know, today's webinar is on systematic review and meta-analysis. And although those terms are now ubiquitous, it is important that we have a basic understanding of the terms and the differences among them. One form of review is a narrative review. This is often what we read in primary research when authors write a literature review. These reviews do not follow a predetermined protocol or document a predetermined plan to search and to screen the literature. And moreover, the results are based on authors' assumptions, and these are often unknown to the reader. So narrative review is not the type of study design that we will be discussing today. Instead, we will focus on systematic reviews and meta-analyses. Systematic review is a study design where the researchers follow a predetermined plan, called a protocol, to make decisions about the search, screening, and coding of the extant literature. The resulting product can be a qualitative or quantitative synthesis of the studies and their findings. A meta-analysis differs from a systematic review in one big way. A quantitative measure of the treatment effect, called an effect size, is extracted from each study, and these effect sizes are synthesized in a statistical model. A meta-analysis typically follows a systematic review, although there are a few instances when this is not the case. But for the most part, a systematic review goes hand in hand with a meta-analysis. As a result, for our discussion today, when we say meta-analysis, we mean a systematic review and meta-analysis. Now, there are several other aspects that differentiate a narrative review from a systematic review and meta-analysis, and let's discuss a few of those now. First and foremost, when researchers conduct primary research and/or write a narrative review of the literature, the means by which the authors collect and report study information is not predetermined, and the authors use their own assumptions and intentions to summarize the literature. The result, as the picture delineates on the left, is a summary of the extant literature that is often less than whole. In contrast, a researcher conducting a systematic review and meta-analysis a priori determines the types of studies that might be included in a review. And as a result, any study that meets those criteria will be included in the review, no matter the researcher's opinion of the study or the conclusions the study found. Therefore, systematic review and meta-analysis, if carried out well, elucidates the entirety of the extant literature. Another aspect that differentiates primary research from systematic reviews and meta-analyses is the size of the studies and their ability to detect statistically significant effects. In primary research, small sampled studies may lack sufficient power to detect meaningful effects. When this happens, a lack of statistically significant effects may mean that a program is not effective, or it may mean that the researchers did not have a large enough sample to confirm that a program is effective. A meta-analysis, on the other hand, combines the results of many studies, large or small, to produce a pooled estimate. The nature of this synthesis means that a meta-analysis has more statistical power relative to a primary study. Similar to the previous slide, systematic reviews and meta-analyses have greater generalizability relative to primary studies. The example on the slide illustrates this pretty clearly. On the left, the primary study includes a sample from Illinois only, and on the right, the meta-analysis includes the original sample, and now also includes 2 additional samples from Washington and Tennessee. The results of this review will now allow meta-analysts to generalize the findings to 2 additional states beyond the original Illinois. And the final difference is how the data sets from each type of study can be used. A meta-analysis can test for relationships between the effect sizes and study characteristics, while primary research cannot. The graph illustrates this point. The graph on the left plots one study's characteristics, the percentage of males included in the study, in the sample, and the study's effect size. Without context, it is difficult to understand if the percentage of males in the sample is potentially related to the treatment effect. The graph on the right, on the other hand, plots the many studies included in the meta-analysis. Now it can be seen that the percentage of males included in the sample is related to the treatment effect. The more males included, the larger the treatment effect. There are, of course, other key ways that primary research or narrative reviews differ from systematic reviews and meta-analyses. But for now, let's move on to a discussion of the different types of meta-analyses conducted and how the WWC's database can play an important role in supplementing these studies. As in all research, an important first step is to formulate a research question and choose the appropriate analytic method to answer that question. Once you have decided that systematic review and meta-analysis is the most appropriate way to answer your research question, methodologists have proposed some steps to follow, and these include conducting an online database search, evaluating and screening the literature, extracting information from each study, synthesizing the information, and disseminating the findings. We're going to start today by discussing how to formulate appropriate research questions for your research synthesis. Let's briefly discuss the types of research questions you might be interested in. And perhaps the most common type of meta-analysis is one with goals somewhat similar to a What Works Clearinghouse intervention report, and that is a synthesis of intervention studies. In these studies, review authors typically ask, what is the impact of X intervention on Y outcomes for Z participants? The example at the right illustrates this question. What is the impact of educational training programs on spatial skills for K through 12 students? The review authors of this study were interested in understanding the information on educational training programs and their impacts on spatial skills. They have limited the studies in the review to K through 12 students only. While a meta-analysis could focus on examining the effects of a particular intervention, similar to what a WWC intervention report does, many meta-analyses examine the effect of a broader set of interventions. By examining a broad range of studies, the meta-analyst has the ability to test and uncover previously untold relationships between study characteristics and treatment effects. And the WWC's websites, for example, provides this contextual information that can be extracted and then used in meta-analytic analyses. And we'll show you how to extract this information later in the presentation. You might also be interested in examining the relationship between two variables or the correlation of two constructs. The general question for these types of reviews takes the form of, what is the relationship between X variable and Y variable for Z participants? The example paper is a famous review conducted by Siren in 2005. The review author synthesized the relationship between socioeconomic status and academic achievement for participants in the K through 12 grades. The review included 74 studies, which included over 101,000 students across 7,000 schools. And of course, these aren't the only types of questions that meta-analyses can address. Review authors also synthesize studies of the prevalence of a phenomenon, such as the amount of bullying perpetration among middle school students. Review authors will also synthesize studies to determine how prevalent certain methodological aspects are. And sometimes review authors synthesize the syntheses themselves. The study listed on the slide, for example, synthesized meta-analyses that examined social skills training programs for various types of students and participants. All this is to say is that there are many different types of questions out there that can be addressed by meta-analyses. Before you decide to conduct a systematic review and meta-analysis in education, however, it will be important to search the WWC's publications to determine if the WWC has already conducted a similar review. This can be done by going to the WWC website, clicking on the menu, and then selecting Search Publications. You can examine the WWC publications to get a sense of the types of reviews conducted by the WWC. The illustration on the slide shows this now. So for example, here I'm querying for any review publication related to children and youth with disabilities. And we can see that there are 36 such publications. In many instances, WWC reviews or the information provided on the WWC website may be sufficient to answer your research question. In other cases, it may be appropriate to consider the added benefit of conducting your own meta-analysis. There are also a few different WWC products that might be especially useful to researchers considering conducting their own meta-analysis, and I'd like to discuss a few of those right now. The first is an intervention report. Intervention reports ask the question, is there evidence that a specific program is effective in improving educational outcomes? The example on the right represents a synthesis of dual enrollment programs designed to improve college enrollment and completion. The intervention report summarizes the results of studies that meet WWC group design standards with or without reservations, and finds that these programs have potentially positive effects on a range of secondary and post-secondary outcomes. Searching the WWC products website for intervention reports on your topic is one place to learn what has been conducted on your topic of interest. Another product to search for is a WWC practice guide. Unlike intervention reports that focus on the effects of a specific type of intervention, practice guides synthesize studies across a broad topic area. They present specific recommendations for best practices suggested by a panel of experts. The practice guide also presents an assessment of the level of evidence available to support each recommendation. For example, the document listed on the screen synthesizes the evidence based on suggested strategies for teaching writing to secondary students. The Find What Works tool is also a helpful resource because it was designed to enable policymakers and practitioners to easily access information on findings from all intervention effectiveness studies examined previously by the WWC. This interactive browser-based tool allows people to search for and synthesize research that the WWC has reviewed, regardless of what product it has been included in, and then filter the results based on the characteristics of the interventions or the samples. In the example presented here, we can see how the Find What Works tool can be used to answer more fine-grained research questions, such as what literacy interventions have been found to have positive effects for public school students in grades 3 through 4. The Find What Works tool can answer this question by requesting information on literacy interventions. We can see that 218 different literacy interventions have been examined by the WWC. And once we see that, we can then apply filters and request information for studies examining the effects for only grades 3 and 4. This then uncovers 27 studies that can then be compared. You can also use the compare feature to answer the research question of whether certain interventions have stronger evidence of effectiveness than others by choosing specific interventions and then examine their study features and effectiveness ratings across different outcome domains. And finally, you can ask the research question of whether studies have examined effects based on students like yours. For example, similar grade levels, racial composition, or urbanicity, by applying the filter in the green box on the top hand part of the left part of the screen. So the Find What Works tool and its accompanying filters can answer research questions such as, is there evidence that a particular intervention is effective in a particular setting? Or do some interventions appear to be more effective than others? And are there studies that have been conducted that focus on a population similar to my setting? A meta-analyst, however, may want to ask additional research questions, such as, do interventions sharing similar characteristics tend to be more effective than others, specifically for 3rd and 4th graders? And this is not something that can be easily answered using the Find What Works tool, but the WWC database does provide information about each study that can be used and easily incorporated into ongoing meta-analyses. So we've discussed a number of different types of research questions that can be examined, discussed questions that can be easily answered using WWC resources, and discussed certain kinds of questions that may motivate using meta-analytic techniques. To motivate the rest of our talk today, however, we will focus on one example research question. The example research question we will use is simple. Within the universe of studies examined by the WWC, what is the effect of educational interventions in general on K-12 students' letter word identification outcome? In other words, we are interested in the effects of many different types of interventions, but on a specific outcome, not simply on one type of intervention. This is a good example because it is couched in a way that the WWC does not currently review, in that it focuses on a specific outcome. Yet in the literature, meta-analyses often conduct reviews focused on a broad range of interventions, but on 1 or 2 outcomes. So in this demonstration, because our goal is to show how to use WWC resources to support a review, we have framed the research question to focus on studies reviewed only by the WWC. Therefore, a real-world application of a meta-analysis would examine the broader universe of intervention studies that examine effects on the letter word identification outcome. For that, a researcher would need to conduct his or her own database search beyond what has been reviewed by the WWC and ensure that all available literature has been found and coded. Now, in addition to that main research question, we will use the WWC's database to answer 2 substantively interesting sub-questions. The first is, are the effects moderated by the student's age? And the second is, do average effects differ for studies with different WWC evidence ratings? Both of these questions will be answered using only the information provided on the WWC's website. The The second question will provide information to a review author that would not be available from the primary studies themselves. WWC evidence ratings provides an unbiased measure of study quality, determined based on a thorough and transparent study review process conducted by trained and certified reviewers. If there are differences in results for studies based on evidence ratings, it may call into question the credibility of findings from weaker study designs. So we will discuss this example research question and its sub-questions through the rest of our presentation. And with that, I will turn it back over to Lauren, who will discuss protocols and other aspects of the review process. Lauren?
Thanks, Josh. We're now going to talk about review protocols. They're the backbone of any systematic review. The protocol frames the scope of the review by documenting study inclusion parameters, such as identifying relevant interventions, time frame, study population, location, and outcomes of interest. The protocol also notes research quality criteria, including study design and standards of rigor, including issues such as attrition and baseline equivalence. The protocol identifies primary and secondary research questions and discusses planned analytic pooling methods and assumptions. The goal in developing a protocol is to specify as much upfront as possible. This transparency adds credibility to the review process and also enables any researcher to duplicate the results given the same scope and parameters. WhatWorks clearinghouse reviews follow protocols developed for each WWC specified topic area, such as the early childhood education or adolescent literacy topic areas. And there's a general review protocol that may be used when individual studies are reviewed. A researcher embarking on a meta-analysis may want to consult WWC protocols when they're writing their own protocol. First, you can check to see if the WWC has conducted a related review on the topic of interest. If so, and if the WWC protocols closely align with the goals of your review, then you may want to consider whether a new review will add substantial value to the field. If a review protocol is not aligned, for example, the time frame is different or the WWC review is more restrictive in terms of population characteristics, such as grade levels or populations included, then it may be instructive to examine other relevant parameters in the related WWC protocol. Examining the WWC protocol may also help in identifying additional questions that need to be explored. For example, you may want to examine effects for particular subgroups that are different from those specified in the WWC protocol. The WWC protocol also may help in identifying what additional literature searching strategies may be necessary or what additional criteria may be needed. For example, expanding the time frame of the review in your study protocol. Importantly, the protocols you develop for meta-analyses are living documents. They may need to be updated as the review progresses. Although it's important to create a protocol so that most decisions are made ahead of time, there'll inevitably need to be some tweaks and revisions. For example, initial searches may reveal that the search string needs to be expanded based on newly discovered keywords or sources, or to address unforeseen analytic concerns. These changes, large or small, should be carefully documented and archived in the review protocol in order to maintain transparency. So now we'll briefly discuss the challenges of the next step, searching the literature, and note how WWC resources may be helpful. Meta-analyses aim to be as inclusive as possible and require an exhaustive search of the literature. A comprehensive literature search that attempts to exhaust all available sources can be very time-consuming and labor-intensive. There are numerous potential resources from which to uncover studies, for example, ERIC, peer-reviewed journals, dissertations, and published research reports. Screening studies to determine whether they are within the scope of the review can be a very large undertaking. The WWC's website has a number of search features available to get a sense of the universe of studies that have been reviewed in a particular topic area. WWC intervention report and practice guide protocols document the scope of the literature search effort, which can help you think about what additional parameters you would need, if any. You can use the Find What Works tool or key searches to uncover individual studies that may be eligible to be included in your meta-analysis. Studies may have been reviewed by the WWC as individual studies or as part of a grant competition review effort. Of course, depending on the scope of your review, additional searching may be required, but using prior WWC efforts that overlap with the search parameters of your review will save time. The WWC also provides ample documentation of the results of their literature search effort that may help someone embarking on a meta-analysis that may have different study inclusion criteria. Here we see documentation that is provided in an intervention report's bibliography. The WWC documents each of the citations that were considered for inclusion in each review effort and notes whether each study was eligible, and for those that were eligible, the study rating. It's possible that the study may be excluded from a review by the WWC, but may be eligible for inclusion in your meta-analysis. For example, you may be interested in a different set of outcomes than those that were the focus of the WWC review. So examining this bibliography can help point you in the direction of additional studies you may want to consider for inclusion in your meta-analysis. So the systematic search and screening process results in a set of included studies in the meta-analysis. The next step is to extract study-specific information about its intervention, design, sample, and effect sizes. In this section, we'll talk through the key pieces of data that are needed to develop a meta-analytic data set, and we focus our discussion on using the WWC database to obtain information that would feed into that meta-analytic data set. This table shell shows the most basic information that you'll need to construct a meta-analytic data set. In general, you'll want to code sample sizes and effect sizes, or the information you can use to calculate effect sizes, separately for each contrast and outcome within a study that meets your criteria. We don't have time today to go into more fine-grained analytic details such as how to calculate effect sizes or how to contend with dependence of samples. But if you're interested, we've created a bibliography that includes various references available to learn more about robust variance estimation and meta-analysis in general, which we'll post online with the archived webinar recording. A researcher may want to begin coding study-specific information and calculate effect sizes based on the original source documents, and then use the WWC database information as a reliability or validity check. Alternatively, in cases where the planned method for calculating effect sizes aligns with the WWC's method, a meta-analyst may choose to begin with the WWC calculated effects, particularly in cases where the WWC obtained needed information that was not available in the original study from the study authors. Notably, when the effect size information is missing in an original article, the WWC queries the author for the missing data. This sometimes results in the WWC obtaining more information about the study than is available in the study. The WWC makes this information publicly available for use by meta-analysts. This is one of the most helpful aspects of the WWC review process to meta-analysts. To retrieve the study and effect size specific information, the WWC website has a feature that enables researchers to download study-specific information that can be used to develop a meta-analytic data set. In particular, you can export 4 files that are linked together in important ways. The Reviews Dictionary file is an informational tool that enables researchers to link the 3 other files together. It summarizes each of the data fields documented in the 3 files and crosswalks which data fields overlap across files. The intervention reports file also is informational in that it documents each of the intervention reports the WWC has published, the number of studies included in analyses by outcome domain, and the overall sample characteristics across studies within an intervention report, for example, grade levels included. The findings and studies files are the most useful to researchers aiming to obtain information to build a meta-analytic database. For each study that meets WWC design standards with or without reservations, the findings.csv file provides outcome-specific details, which are the most critical pieces of information that you'll need to conduct meta-analyses. The studies.csv lists all studies that have been considered by the WWC and the characteristics of the study, which is likely also necessary if your research question involves subgroup analyses based on study characteristics such as study setting or research design. So you can export and download the full individual study database by going through the following steps. You'd go to the homepage of the WWC website, click on the menu tab, and then click on Find Evidence. Then select Data from Individual Studies. From there, you'll be able to select Download Data from Reviewed Studies. When you click on this, it enables you to download a zipped folder that includes the 4 files that I just discussed. I'm going to dig a little deeper into the findings.csv and studies.csv files. The findings database includes outcome-specific information that can be included in the Meta-Analytic database. This is an excerpt from the studies in the database that examine the effect of the Woodcock-Johnson 3 letter-word identification outcome. As you can see in this example, studies were reviewed under different protocols, are examining the same intervention, have different kinds of comparison group experiences, and include samples from different grade levels. The findings.csv file also provides outcome-specific findings that can be added to a meta-analytic database. As you can see on the slide, each row represents information from a separate contrast reviewed by the WWC. The column headings provide clear statements about what is contained in each. For example, the means and standard deviations of the intervention and comparison group are clearly labeled intervention mean or intervention standard deviation. Effect size study represents the effect size provided within the study itself, and effect size WWC is the effect size calculated by the WWC. On the far right, you can see that the information about effect size's statistical significance is also provided. One last thing about this spreadsheet. Later in the presentation, Josh is going to discuss using the spreadsheet to conduct a meta-analysis. He's also going to talk about combining this spreadsheet with the spreadsheet I'm going to discuss next, the studies spreadsheet. To do so, you'll need to use the review ID column listed in the middle here. Moving on, okay. The studies.csv file lists all citations and study ratings for all studies reviewed by the WWC and documents characteristics of those studies that meet WWC group design standards. As can be seen here, this includes information about the intervention name, study design, and its rating. For studies that meet WWC design standards with or without reservations, this spreadsheet includes information on study design and characteristics that may be useful in a meta-analysis. Now, this spreadsheet is quite large, and therefore we're not able to show you a screenshot of all the information available. But to name a few things, however, this spreadsheet includes information about the delivery of the program, the sample characteristics such as students' gender or race ethnicity, the age or grade of students, the region of the country the program was conducted in, the types of schools included in the sample, the type of publication, and the date of the original publication. All of these characteristics can be extracted and utilized in a meta-analysis. For example, as Josh will show you later, a researcher may want to compare the pooled effects of results based on studies that meet WWC group design standards with reservations versus those that meet WWC group design standards without reservations. This file includes information on the WWC's rating that can be inserted into your own codebooks and used in later analyses. We therefore suggest that when you're conducting your own meta-analysis, you consult the findings and studies spreadsheets to validate your findings and extract potentially missing information. It's truly the most valuable resource for the meta-analyst. In addition to the information in these data files, WWC's products, such as intervention reports and practice guides, can provide additional useful information that may help address discrepancies between what is reported in the original study and what the WWC reports. The decisions made by the WWC may help inform certain methodological decisions a meta-analyst may make in terms of including or excluding particular findings, calculating effect sizes, and documenting specific study parameters. WWC products often explain why only select study results are reported by the WWC. In some cases, it may be that certain outcomes are outside the scope of the review protocol. In other cases, particular analyses do not meet WWC design standards. For example, here's an excerpt from an intervention report that describes outcomes that did not meet WWC design standards due to overalignment and lack of reliability information. A meta-analyst who is also concerned about issues of overalignment or outcome quality may benefit from additional information the WWC may have uncovered regarding these issues. A second way in which WWC products, such as intervention reports, can be useful is by providing additional information about why effect sizes and p-values reported by the authors differ from those reported in the original study. The WWC applies post hoc adjustments, such as adjustments for clustering, when the original authors did not properly account for the mismatch between the unit of assignment and the unit of analysis. Footnotes also provide useful information about why there may be discrepancies between author-reported effect sizes and WWC calculated effect sizes. The footnotes also will note when information from author queries were used to calculate effect sizes. So this example shows a footnote in the main impact table that documents issues such as the WWC's application of an adjustment for clustering and how the WWC calculated effect sizes. Third, WWC products often provide more narrative contextual details, such as information about the comparison group experience and training and support for implementation. This information might also be useful for future meta-analyses. So in this example, all studies that meet WWC group design standards with or without reservations have a section where study details are narratively described. Here we see the description of the teacher training component for the intervention, which could be considered as a potential moderator in a meta-analysis. Finally, I'd like to point out the importance of keeping track of when samples, meaning study participants, overlap in the findings database. The WWC findings database includes all results of studies that the WWC has determined to meet WWC group design standards with or without reservations. Samples can overlap for two main reasons. First, the WWC reports on full sample findings as well as subgroup findings from the same study when the particular subgroup has been designated to be of interest in the review protocol. The findings file contains a field that flags subgroup findings. Second, multiple effect sizes may exist for the same or very similar samples. For example, results may be included from two different time points. Another example is results from a multi-armed study in which multiple intervention conditions are compared with the same comparison group. Meta-analysts have a variety of ways of handling this dependence issue, and we encourage you to seek out additional resources to learn more about this. But in general, it will be important to document when studies report the same outcome measures multiple times in a study and how you handled it in the meta-analytic model. This will influence how you will structure and analyze your data set and potentially what software package you'll select to analyze results, as there are many different options that all have comparative advantages. In our example today, we will use a procedure called robust variance estimation, which Josh will go into more detail about shortly. I'm now going to turn the presentation back over to Josh to give you a little taste of what you can do once you have your meta-analytic data set ready for analysis.
Thanks, Lauren. We now turn to the last step in conducting a meta-analysis, analyzing the results. All the programs listed here on the slide and many others will conduct at least a basic meta-analysis. And please note that IES doesn't endorse any one specific program. But today we will focus on one of those programs listed here, the statistical environment R. R has become a popular choice for theoretical and applied statisticians and methodologists over the past decade. It has several advantages. First and foremost, that it is free, but also that there are now numerous free and accessible tools and websites dedicated to making it easier to conduct analyses. In addition, the free RStudio software gives the analyst many helpful tools for organizing files, writing scripts, and producing results. Moreover, the R community of package authors has contributed greatly to the field of meta-analysis. Last year, along with my colleagues Emily Hennessy and Emily Tanner-Smith, we conducted a review of these R packages for meta-analysis. At the time of our last search, in June of 2016, we found 63 packages that were dedicated to conducting some aspect of meta-analysis. In the paper listed here, we grouped the packages into categories by content. A number of the packages are what we call general purpose packages that can easily be used to conduct basic analyses and produce plots. The last part of today's webinar will focus on one of those packages. Just to refresh your memory, for this presentation, we are investigating the following primary and secondary research questions. Our primary research question is, what is the effect of educational interventions in general on K-12 students' letter word identification outcome? We will compile all relevant effects in the WWC's findings database to answer this question. Our two secondary research questions examine whether the effects are moderated by students' age or WWC study rating. We will code students' age into two groups, pre-K versus kindergarten or older. Study ratings are coded as meets WWC group design standards with reservations versus those without reservations. So let's turn now to using R to analyze the publicly available data sets that Lauren discussed earlier. I should note that most of the remaining slides include R code, but I do not plan to discuss those in any detail. To get started, the first thing you will need to do is download and load the appropriate R packages. For this demonstration, we use two packages, dplyr, which is great at manipulating data sets, and the robo meta package, which will be used to conduct the meta-analyses. Both of these packages, again, can be downloaded for free. Now, after we download the packages, we upload the findings and studies data sets. From the findings data set, we calculated the effect sizes variance using the effect size outcome sample size column. The effect sizes variance will be used to weight the studies included in the meta-analytic model. Next, we located the rows that contain the outcome we are interested in. In this example, we needed to extract information pertaining to the letter word identification outcome. The code highlighted below lists the various ways the outcome is represented in the data set. For example, the phrase letter word with a hyphen between letter and word, or simply the phrase letter identification. Using the code listed on the slide allows you to extract all of the rows that contain only these words and can then be used to conduct the meta-analysis. To incorporate information about the WWC rating, we next need to merge the newly created data set that includes only the letter word outcomes with the studies data set. To do so, we use the merge function and match the two data sets on the review ID column. The review ID column contains a unique number corresponding to each study's review. Matching the two data sets on this number allows study-specific information from the studies data set to be merged into the letter identification data set we just created. This one large data set now includes all the information needed to conduct our meta-analysis. Finally, we created the pre-K dichotomous variable using the grade level information. This variable identifies samples that are pre-K only from samples that include kindergarten age children or older. Once the data set is created, we inspect the contents. The data set has 118 total rows. Not all of these rows have effect size information, however, so only 106 rows will contribute to our analyses. This includes information from 71 total WWC reviews and 40 different interventions. Across the 118 rows, 62 are from studies that meet WWC group design standards without reservations, and 56 are from those studies that meet WWC group design standards with reservations. Finally, 88 of the effects are from pre-K samples, and 30 are from kindergarten or older samples. The code listed on the right illustrates just one of the many ways this information can be obtained from the data set. So we now have all the information we need to estimate the meta-analytic models. On a technical note, we are using the ROBU meta package because it handles the dependencies among the effect sizes within each study. Simply put, when authors measure and report multiple effect sizes in the same study using the same sample, the effect sizes within the study will be correlated, or what we call dependent. Traditional meta-analytic models assume that the effect sizes are all independent from one another and derive from different samples or different studies. The ROBU meta package instead uses a meta-analytic technique called robust variance estimation that accounts for these dependencies among the effect sizes. And thus, the model's results produce estimates that take into consideration all available information and provide an accurate meta-analytic estimate. More to the point, once the data set is ready, the R code to conduct a meta-analysis using ROBU meta is relatively simple. The code, which spans only 4 lines, can be found to the right. The results of the meta-analysis indicated that in general, students participating in educational interventions examined by the WWC score higher by a statistically significant margin on letter word identification outcome compared to those students in the comparison group. And that average effect size is 0.17. The table at the bottom of the slide translates the average effect into the WWC Improvement Index, which is a measure of the expected change in percentile rank for an average comparison group student if that student had received the intervention. So in other words, on average, a comparison group student scoring at the 50th percentile on the letter word identification outcome would be expected to achieve a 7 percentile increase should they participate in one of the programs included in this synthesis. We should note once more that, of course, this analysis does not represent a true systematic review because it is based only on the studies reviewed by the WWC, and we didn't do our own search for other eligible studies. We are only presenting these results to illustrate what one could do with the WWC information. And if you wish to use this information, we suggest that you use it in conjunction with a full systematic review. Going a little bit further, though, it is also possible to conduct meta-analytic moderator analyses using the WWC's data. This is an example of how students' age is related to the average impact on the letter word outcome. The bar graph on the left illustrates the differences in average effect sizes, comparing those of students from the pre-K samples on the left bar to students in kindergarten or older samples, shown on the right bar. The results indicated that the average effect on the letter word identification outcome for pre-K students is larger than the effect for students in kindergarten or older samples. However, as the results indicated on the right, that difference is not statistically significant. Now, we may also be interested in an analysis of the WWC's rating as a moderator. The column on the left indicates that the average effect size for studies that meet WWC group design standards with reservations, and the column on the right indicates the average effect size for studies that meet WWC group design standards without reservations. And as can be seen here, the average effect size for studies that meet WWC group design standards with reservations is 0.25. And the average effect size for study results that meet without reservations is much smaller, at 0.12. And now the difference between the two groups is statistically significant, as indicated by the test statistic and the p-value on the right. And the code on the right also indicates how to conduct these analyses in R. The last piece of our analysis I will show you is a meta-analytic forest plot. A forest plot is a visual representation of the effect sizes included in the review. Each row represents a different effect size, The size of the sample is represented by the size of the shaded box, and the effect size's 95% confidence interval is represented by the line that runs through each box. At the bottom of the graph, the small triangle, which is circled on the screen to make it easier to see, represents the meta-analytic effect size and its 95% confidence interval. The example shown here is an excerpt from a larger forest plot that includes all 106 effect sizes included in this analysis. Now, the unique aspect of this graph in particular is that it represents both the studies and the effect sizes from each study included in the review. The bold numbers, in this case, represent those review IDs we saw in the findings data set earlier from each study, and the unbold numbers represent the individual effect sizes included in the study. So if this was your own meta-analytic forest plot, you would want to change those numbers to meaningful words that represent the studies and the effects, typically the author's last names and then the measurement names. Now, taken together, this graph provides a quick way to visualize the number of effects included in the review, the variance between those effect sizes, and then how the overall meta-analytic effect size compares to each included study. And with that, I'll turn it back over to Lauren, who will conclude the webinar, and we'll turn to the Q&A. Lauren?
Thanks, Josh. Today, we've provided you with a brief overview of the process of conducting a meta-analysis and have focused our attention on how the WWC database can be used to support data collection. We recommend that you should always first think through whether the information available through the WWC and the Finding What Works tool can help you answer your research or policy question of interest, or whether a new systematic review may be necessary. We encourage you to think through whether meta-analytic techniques will be appropriate to answer your question. We also talked today about how WWC resources can be useful in streamlining literature searches and uncovering additional needed data that may not be available in the original published paper. We recommend you take advantage of these resources to help minimize the burden of data collection needed to conduct a thorough meta-analysis. Finally, we gave you a glimpse of the kinds of findings you can present using meta-analytic techniques. Meta-analysis is a powerful technique, and we encourage those of you who would like to learn more to reach out to us for suggestions for further resources to explore. Please feel free to contact us at these email addresses. And with that, we'd like to open it up for questions. I see that there are some people that have asked a few questions, but if you still have some burning questions you'd like to ask, feel free to use the questions toolbar on your control panel.
All right, excellent. So this is Chris Weiss again. I'll be helping to moderate the questions and the question and answer. I'm going to, I hope you guys, Josh and Lauren, have received the information I've been feeding to you, or trying to feed to you. So I'd like to start with a question for Lauren, which is, how do we find past review protocol? For example, where would I find the protocol used for the WWC product, strategies for post-secondary student in development education, a practice guide for college and university administrators and advisors and faculty?
So thanks, Mike, for asking the question. And so just like the way we showed you how to find intervention reports, you can do the same kind of query on the WWC website to search for particular protocols. There's a filter where you can actually look for protocols. You could also look at the actual product, and Chris, you can tell me if I'm wrong, but I'm pretty sure that every product, it will say what protocol was used as part of that review process.
That's right. Yeah, that is true. Mm-hmm. That is absolutely correct. Yes. So thank you, Wayne. Josh, we'll try to alternate the questions between them, between our two panelists. Josh, a question for you. With moderator effects, how are we sure that the effects are not due to the intervention itself, and not the moderator or variable?
Yeah, that's an excellent question. Thanks for asking it, whoever provided that question. I think it's important to recognize that both the meta-analysis itself and then the subsequent moderator analyses that we conduct, these are both observational style studies. In other words, we are not randomly assigning the interventions or the studies to different conditions. And as we all know, that random assignment is the best way that we have to talk about causal claims. So my answer is pretty simple to that question. We don't know if it's due to the moderator of interest or the treatment effect itself. There are different techniques that we could use to try to limit how confident we are or unconfident we are in the results of the moderator analyses, such as using multiple meta regression. So this would be where you include multiple covariates in your meta regression model, something we didn't talk about during the presentation. And maybe by doing that, you see that there are two moderators that are sort of confounded with each other. And now maybe you can be more confident that the treatment effect itself is causing the difference. But really, to answer your question, it's difficult to say for sure. The reason why we do moderator analyses, however, I'll just end with this, is that we're interested in if there is a differential treatment effect, and those moderators help provide that information.
Excellent, thank you. Let me ask I can take a question here that a couple of people have asked, which is about, for those who may have joined the webinar a little bit late, whether there is a recording or whether there will be a recording. Yes, I can say that the webinar is being recorded, and we will post it as well as some of the materials, including, I believe, bits of the R code that Josh showed, to the IES website in the very near future. So Lauren, if I may, I'll pass this question to you. Do we need IES permission to use What Works Clearinghouse data for meta-analytic purposes?
Absolutely not. The data is, I think, and Chris, you can jump in here too, but I think that part of the reason why the Finding What Works tool was created and the database, the exportable download database was created and put on the WWC website was to offer it to the public. And so, it's there for the taking. And I don't know if there's anything else that you wanted to say, Chris, about that.
No, other than please do. It's not only acceptable. We really do encourage anyone to use the data. Right, as Lauren mentioned, the clearinghouse is a product of the U.S. Department of Education's Institute of Education Sciences. We are taxpayer funded, and it is part of our mission to make the resources that we create available to all. So that could be the products that we produce, the intervention reports and practice guides, and that extends to the data that we have as well. I'm fumbling with words to say please do, and to say not only is it okay, we very much encourage researchers to do so, and to please help us spread the word about the availability of these data. So Josh, I got a question for you.
Yes.
What are the benefits of performing clearinghouse only or WWC only meta-analyses rather than traditional meta-analyses, if there are any as such?
Yeah, that's a good question. I think I'll start off by saying that, as I think Lauren and I mentioned a couple times, the example meta-analysis that we showed here is not based on a systematic review. And it's, of course, intervention reports or practice guides that the WWC produces. Those are, of course, based on systematic reviews. But what we're talking about here is extracting individual studies that happen to be about a particular topic and putting those into a meta-analysis. So I think this is my opinion alone. I think the way I would suggest using the WWC resource is in conjunction with a systematic review and meta-analysis. I believe strongly that a systematic review is the best way to ensure that all available data is collected and coded and then meta-analyzed. And so using the WWC's resources sort of in a vacuum without doing systematic review as well would not ensure that all available information is used. So that's not, of course, to limit the scope and the usability of this information. I just want to be cautious with using it on its own. Of course, it can be used in the way that we've done to sort of showcase what is available, or if you're interested in a very specific question, or if we're using it for teaching purposes. It's a really great resource for all of those angles. But if you're interested in sort of talking very specifically or answering a large research question about the universe of studies, I think that the WWC's resource needs to be used in conjunction with a systematic review. Chris, do you have anything else to add there? Because I know you've.
No, I think that's fantastic. I think that's very helpful.
Yep.
Thank you, Josh. So, Lauren, I'll pass a question from Li Fang to you, which is, Li Fang writes, if I can't find, any study related to an intervention, does that mean all current studies do not meet what works clearinghouse criteria?
Can you repeat that? If you can't find a study
that's related to an intervention, does that mean all current studies do not meet clearinghouse criteria?
Well, so you know, so the What Works Clearinghouse, if they have in a specific topic area, the What Works Clearinghouse does not necessarily review every single intervention. They choose specific interventions to do a thorough, exhaustive, systematic review on. And so, you know, within, say, adolescent literacy, there's select interventions that have been studied. But there are also, that's for intervention reports. But sometimes studies WWC reviews happen for other interventions if it's part of a practice guide review, or if it's done as a single study type of review. There's a product called single study reviews that the WWC used to have, and there's also just individual studies that have been reviewed for the WWC for grant review efforts and other things. So the WWC database has studies reviewed from across, any study that's been reviewed by the WWC would be in there. So you could do keyword searches in addition to looking at intervention reports if there's a particular intervention you're interested in and you want to see if there have been any studies done. So it might be that the study has been reviewed. It might be that studies have been reviewed, but that don't meet standards. If you look in an intervention report like I showed you in the bibliography, it will tell you all the studies that didn't meet standards or that were not eligible as well.
That's right. Yes, and just to sort of reiterate some of what Lauren just said. The database that is available and what you both through the download of the Excel files or the CSV files and on the through the website itself, included in those are all reviews that we have conducted or that have been conducted for the clearinghouse, and that includes those that meet standards with or without reservations and those that do not. So it may be that a study that doesn't appear there or an intervention that doesn't appear, that the research on it hasn't been screened yet or reviewed yet. It could be for other reasons. So I guess I hope we provided enough information. I think the short version would be it doesn't necessarily mean that there's no information, there are no studies on the intervention. Josh, let me ask a question from Kelly Heyman to you, which is something that I was curious about as well, about software. And Kelly's question is the RoboMeta package available in Stata or software other than R? And if so, does it differ? And I think, we could actually, there's probably other people interested in what are other similar routines within other software packages that might be similarly useful.
Yeah, that's a great question. So I'm not as familiar with Stata, but I do know that there is that the robust variance estimation, there is a procedure in Stata. So to answer your question directly, yes. I believe that they're working on implementing it in SPSS, but I do not think that has been completed yet. So those are the Stata and R are your sort of main choices if you want to conduct a robust variance estimation procedure. It's a little bit, and the reason why it's just a little bit more complicated. You have to use a little bit more of a complicated algorithm to conduct the analyses, and therefore some of the more traditional basic software packages that are usually available to meta-analysts aren't available. Your second question asks, are there other procedures that will, I'm assuming what you mean is, are there other procedures that will account for the correlation among the effect sizes or the dependency among the effect sizes? And the answer to that question is yes, there are, or there is, one in particular, and it is multi-level meta-analysis, and this is in the same vein as a multi-level primary analysis. And so under certain circumstances, you can use the multi-level model framework. In fact, I believe the hierarchical linear models software that was very popular in the 2000s especially, will implement these procedures. In R itself, there are a number of packages now that will implement multi-level modeling for meta-analysis in R. So RoboMeta is just one way to conduct these analyses. And in case that it wasn't clear in the presentation, I use it in particular because it's, once you get your meta-analytic data set up, the code is relatively straightforward, and it only takes a few lines to run the analysis. But there are other ways that you can go about conducting these analyses. So I hope that answers all of it, Chris.
Yeah, fantastic. Thank you. Thank you, Josh. So, Lauren, a question about sample size, which is, what if the sample size is small? Can we still perform meta-regressions or meta-analyses?
So sample sizes of, I mean, the nice thing about meta-analysis is, and Josh mentioned it during the presentation, is, if an individual study has a very small sample size, it may not have power to detect significant effects, but if you're pooling similar studies of the same, intervention, and you see consistently that these small studies are finding a very similar effect, you might feel a lot more confident in the results as compared to if you had just done that one study. Now, in terms of pooling together, doing a meta-analysis when you only have, 3 or 4 studies, obviously it's the same type of issue where, you don't have, you might feel a little less comfortable. You might not find those significant effects because now you still say you have 3 studies. All 3 studies have very small sample sizes. You might have a much harder time, finding some consistency across the, effect sizes. There might be a lot of variation. And so the more, just like in any kind of study, the more you have, the larger the sample size you have, the better, especially if you want to do moderator analyses. You'd really want to have more studies in your meta-analysis. I don't know if Josh, if you wanted to add anything else.
I'll only add that the minimum number of studies needed to conduct a meta-analysis is 2. And of course, course, those are not interesting meta-analyses in particular, but that's all you technically need. And I'll just add one more thing. When we're talking about meta-regression, some of the, just like in primary analysis, as you add more covariates to your model, it requires more degrees of freedom, or in other words, in this case, studies. So if you want to run a complex meta-regression model with lots of covariates or lots of moderators, you will need more and more studies. So to do a basic meta-analysis, I just see a question come in here. The minimum number of studies to conduct a basic meta-analysis is 2. That's 1, 2. But if you want to do a complex meta-regression that includes lots of covariates, you're going to need more and more studies. And the number of studies really depends on how complex the meta-regression model is.
That's fantastic. Thank you. Thank you. Yeah, this is great. So there are a couple of questions here, and I'm going to put these to both of you, and because I'm not quite sure about, yeah, I feel like it's a broader discussion. So there's a question about single case design research. Actually, there are a pair of questions about single case design research. So a majority of intervention studies in special education and some other fields use single subject research methodology. Is there analytical software to conduct meta-analyses to calculate effect sizes for single case design studies that could be used for meta-analysis?
Yeah, so I'll take this question, Lauren.
Sure.
So there are, especially in the last few years, really in the last maybe 5 or 6 years, there's been a really healthy amount of research that has come out that has helped meta-analysts think about using single case research in meta-analyses, and also calculating effect sizes from single case designs that can then be incorporated into existing traditional two-group meta-analyses. So for those interested, if you look up, it's mainly led by Larry Hedges and the late Will Shadish. They both have papers that talk about calculating effect sizes from single case designs. I'll also mention that there is at least one package that I know about in R. There might actually be a few more that I'm forgetting off the top of my head. But there's a package called SCMA. I think that stands for single case meta-analysis. And it does exactly what it says. It calculates effect sizes from single case designs, and then it will also perform a meta-analysis of those single case designs. And the last thing I'll mention is that there are packages that will extract information from graphs in PDFs. So this is a pretty popular way to analyze data in single case designs. You've got a graph of, it's usually a flow chart where you've got the time on the x-axis, and you've got different participants on the y-axis, and there's actually software out there that will extract that information in a figure that isn't quantitative and turn it into quantitative information that you can then use to calculate effect sizes. And so there's packages in R that will do that as well. Lauren, do you have anything else?
No, the only thing that I just wanted to point out, because we didn't mention single case designs today, and a big reason why was because we were focusing on the What Works Clearinghouse database, and the downloadable files, the findings.csv would not include any information from single case designs.
That's right. We probably have time for one more question. I'm looking over those that are those that have come in. So I think there are a few sort of more technical questions that we can reply to directly. about some specific model specifications, etc. Let me ask, and you guys can talk about this. So one of the panelists, one of the participants asked, do panelists recommend any online resources or webinars to learn more about R? Or I would also add, the specific elements of the software that were demonstrated today.
Well, Lauren, do you have any in particular you want to bring up before I?
No, you can, if you have any that you think.
Okay. Yeah, I don't, unlike, say, 5 or 10 years ago, there is now a plethora of our information. I would recommend, if you're starting out completely from scratch, joining a MOOC, a massive online course. There are a number of courses from, I think there's one from UCLA and from Columbia that teach basics of R. That's certainly one way to start out. There are a number of great books out on specific R packages that you can read and that are very accessible. I don't know if I'll recommend one in particular because, frankly, there's so many that are all fantastic, especially the ones that have come out in the last few years. In terms of doing meta-analysis in R, I'll make one more small plug for the paper that I mentioned that I did with Emily Hennessy and Emily Tanner-Smith, only because we, in addition to collecting packages, we also provided some accessible R code that sort of walks step by step. I'm not the only one to do that, though. If you look in the R packages themselves, they often will provide step-by-step ways of conducting analyses. So in particular, one popular package is called Metafor, METAFOR. And that particular package has a very great help resource. It's actually called a help document in the R package. And it will walk you through all the different types of meta-analyses you'd ever want to conduct using that R software. So if you're completely new, I think I'd start with like a MOOC or some sort of online software. There's a lot of them out there. If you're a little bit more advanced, I'd look for a specific package or specific type of analysis you're doing and go for a book. And if you're specifically interested in meta-analysis, I'd start by taking a look at the paper that I did or look specifically at certain meta-analysis packages.
Excellent, thank you. And as I said, I believe the remaining questions are ones we can address. And they mostly deal with technical and very specific issues. So we can take care of those, and we'll send out the email that goes with the link to the webinar recording at a later date. So yes, I think that this will conclude our webinar. Josh or Lauren, do you want to bring us home, or I'm happy to sign us off as well.
Go ahead, Chris.
All right. So on behalf of all of the panelists here, I would like to thank you for your participation. Thank you for your questions. And on behalf of the Workbooks Clearinghouse, I'd like to extend my special thanks to Lauren and Josh for a terrific and informative presentation. Thank you all very much.
Thank you. Have a good day, everyone.